Hello, hello. Good morning, afternoon, or night, I guess, depending whenever you're watching this. This is the first installment of the Unofficial IntroPsych archives. It's where I take a topic that you either voted on or I decided was important and explain it a bit more, go a bit deeper, perhaps elaborate on some concepts that may be points for concern, and that's exactly what we're going to be doing here. You'll see behind me a diagram. This is the diagram that we'll be using for most of the course pertaining to the visual system, and it talks about the primary visual system, as we say. Right here, I'm sure this looks familiar. Let me run you through the brief parts that would be familiar, and then the additions to it. So you have your eyes. I trust that you all know what eyes are. And at the back of the eyes, what do we have? We have the retinae, which is plural for retina. So each eye, we've been taught so far, has one retinae. But it's a little bit more complicated than that, actually. So at the back of each of your eyes, you actually have two sections of your retina. And that has some important implications. We call this, the inside, the nasoretina. Why is it the nasoretina? Because if we think about what nasal means, nasal, nose, nasoretina, it's referring to the retina on the inside, closest to your nose. So nasoretina. And then on the outside, which would be right here and here, we have the temporal retina. So nasal, temporal. And the reason our retina is broken up into two sections is because it allows us to do something rather unique. Think about it like this. Before, you might have assumed that this is called your right. Pretend this marker works. This is your right visual field, and this is your left. Before, you might have thought that the right visual field is controlled by the right eye, and that the same might be true for the left. So left eye controls the left visual field. But this actually isn't the case. Instead, we see this. As we discussed, remember, nasal, inside, nose, temporal, outside, right here. Interestingly enough, and if we think about it geometrically, it makes sense. Your right visual field, so if I'm looking at you right now, this side of me is not controlled by this eye in particular, but instead the temporal retina, so looking out this way, and the nasoretina on the right side. So left temporal, right nasal, because it faces this direction, right? If my right temporal retina is here, it's geometrically facing this way. It can't look at my right visual field. And that's true for most cases. It's why we look forward. This grants us the ability, because we're a predatory species, to sense depth in particular is one of the big advantages. But this has some interesting implications, and we need to talk about those. So right, left visual fields, and there's a crossover effect here. We see it crossing over. I trust that makes sense at this point. And remember, one more time, nasoretina, temporal retina. Okay, I'm sure at this point we've heard that visualization in the brain, or visual processing is probably a better way of putting it, is actually controlled on the opposite side. So if we look at this, again, the term we used was visual field. So the left visual field is actually controlled by the right hemisphere. And hemisphere, as I'm sure I've mentioned in the course already, just refers to half of your brain. So take a slice down the section, or the center rather, and split it in half. You have your left hemisphere and the right hemisphere. These each control for one visual field, the opposite visual field. And in order for that to work, something needs to happen, right? Because if the left visual field is being controlled for on both sides, then in order for both of it to end up on the right side, one has to cross over. And where does it cross over? Something called the optic chiasm. And one trick for you as far as anatomy, you've heard the terms optic nerve, optic chiasm, and optic tract. Remember NCT. Come up with whatever terminology you want for that, but these are letters that go together quite well. I find that helpful. So nerve is at the top here. Nerve is before they cross over. C, the chiasm, is when they cross over. And then the tract down here, the optic tract, is right after. So NCT, and I hope you can see that. I hope I positioned the camera correctly. So that actually has some pretty implications. It may seem boring and not that important at first, but it's pretty important. And the reason why it's important is in the case of lesions. Okay, brief cut there. We just talked about why all of this exists. Now we're going to talk about what the implications are. And the implications typically deal with the pathological nature of this or lesion studies. We call something a lesion if it causes damage to this brain area. So hypothetically speaking, were we to have a lesion, so damage, think about some sort of trauma, whether or not a stroke destroys this area, just a simple head injury, whatever it might be. Let's say, again, let me just rewrite this on this side, NCT. So the bottom here is tract. Let's say we have a lesion to the left optic tract. Okay. Now, what does the left optic tract control for? As we just discussed, you have your left and your right visual field, and any lesion here will impact one of these. It will impair your ability to process the information that is coming from either half of one of these, an entire section, etc. And so the left optic tract, let's follow it up. Red, red, red. Okay, right, come here, right. That's interesting, it makes sense. The left optic tract, we remember that we discussed it crosses over. The left hemisphere controls for the right visual field. So if there's a lesion to the information coming in to the left hemisphere, then it's just not going to be processed. And cross this out. And there you go. Suddenly, you do not have information in your right visual field. But that's the simple one. That is where things are a lot easier, because at this point, it has converged. At no other point has it really converged in the same intuitive way. Let's take another example. The optic chiasm. Remember, nasal meaning nose, so inside, closest to the nose, crosses over. So we have the left nasal comes to the right side, etc., etc. We see the same for the right side. But what if we just cross that out? Think to yourself, what would you expect to see here? So both nasal retinae have been damaged. I'll give you a second to think. Okay. Before I spoil it, say it out loud to yourself or whatever you need to do to make this information salient. So we'll come here. We know that the nasoretinae lead to the optic chiasm, so let's follow them. Nasal, it leads to the outer portions of the right visual field and the left visual field. So instead of this here, I'll just redraw that briefly. Because the visual field is split into two, we can do this. Split that. And the outer portions have been cut. And I'm sure you can see where I'm going with this. I doubt I need to do another example. I think the general idea is there. Up here, you can actually have a lesion on only one of these because they haven't actually converged yet. On the diagram, it looks like they're close, but you can have one on, say, just the left nasal retina, which again would impact the outermost portion of the left visual field. But the principles apply. Just look at the visual field, understand that the nasal crosses over, understand that they've converged by the optic tract, so again, NCT, and you should be fine. I wanted to go over this because while it's intuitive once you get it, the underlying principles don't really make sense. Because who knows why the brain evolved to flip hemispheres, evolved to be contralateral, we would say. We don't really know. We can hypothesize about these things, but we kind of just need to accept their existence and go from there. So this is all I would like to talk about regarding this. I hope it sort of added a little bit of context to this diagram as a whole. Oh, one thing briefly before I close out. Left hemisphere and right hemisphere, if we're talking about the primary visual cortex, or primary visual pathway rather, refer to the LGN, so the lateral genucleate nucleus, and then that leads into V1, which is the primary visual cortex, so occipital lobe at the back here. That's what the hemispheres are talking about. But other than that, I think this makes sense. I hope I did an all right job. This is the first one of these that I'm doing, and I'm kind of rushing to get it out for you because school was canceled and we didn't have our tutorials. So I'm doing this at like 9 p.m. at the school that's technically closed down. But I wanted to get this out to you because I think it's important that you have a day to digest this information before your quiz on Friday. So other than that, feel free to send me an email if this doesn't make sense or if I mess something up. Entirely open to emails. Along with grading and stuff, I'll talk more about next week. I'd like to talk about that in front of the whole class, but if you do have any issues with that or regarding that, please do email me. I try to make myself as open as possible. But other than that, I will see you on Wednesday, and good luck on your quiz.